Now we have completed doing a work when your stack is falling. So we only have a third point to understand, like how recursion is working. After understanding this point, I will move to the actual question like Tower of Hanoi and all the other questions, okay, recursion and all, like Fibonacci series, okay, in recursion. Okay, so just please understand this one, and this is very important. So doing a work before a call or after a call, you can say in a second manner, doing a work like in building a stack as well as falling a stack. Okay, I will not show you a code this time. So I have written here what you have to print, like 5 4 3 2 1, okay, and 3 1 2 3 4 5. So you can check from previous videos, right? This is a work when building a stack, right, when your stack is building, and this is a work when you can say when your stack is falling, right? Now do not watch this video directly. If you are not able to solve this question, then watch, okay, otherwise just give a try once, okay. Now move to the intelligent. So let me write the code for you. See, so I have give a hint to you. This is a building a stack and this is a falling a stack. So now say I can write print d, or directly say print sequence integer n, okay, and let me give the modifiers to it, public static void, okay. Now what I want to do, as out I need to print my n because this is my repeated work. And how will I achieve my repetitive work? You know that, right? How I do that? I will say print sequence and n minus 1. This is a way of achieving it because I need to go to my base case, and for going base case I need to decrease my input, or I need to make my a larger problem a smaller problem. I hope this is making sense, right? Not 1 0 return, okay. Now this is your a code similar to your first problem, right? You're doing a work by building a stack. Now s out again, and so if I run this code, the output will become directly, but I know that, okay. So let me, what I need to do, comment it, okay, and I will say print sequence 5. Let me show the output directly. Run introduction, okay. This is recursion introduction, that's why I choose this name, nothing else. So you can check 5 4 3 2 1 1 2 3 4 5, right? And now let me show you the stack. If you say Ashwini, I do not understand how it is working, so let me put a debugger to it, okay. Debug. So if you can check, your program came here for n equals to 5. Now on console 5 printed, okay. Now again it goes to n equals to 4, n equals to 3, n equals to 2, 1. You can see the console, your 1 is printed, 5 4 3 2 1, and your stack is built properly. Main 1 2 3 4 5, your 5 calls is here. Now you will call for a 0. Now it start removing the values from your stack, right? Calls, method calls from stack, and after this your halting point, you have write this line. And what this line is, when, yeah, there is a, here is a one tricky part. If you are understanding a recursion first time, you can ask me, hey Ashwini, here's a n equals to 5 4 3 2 1. The call goes in a increasing direction, like, sorry, right, and 5 4 3 2 1, and it is a like decreasing, like 5 4 3 2 1, right? And why it is coming like 1 2 3 4 5? It should come into the, like, in the direction it is goes. It's not happening in a stack, okay, because what is a property of stack is? Let me make you understand. Because compiler use a stack memory. Compiler use a stack memory, because you can ask me, right? This is a your stack, and here you are calling for 5, 4, right? And 3, 2, 1, and here 0. And when it's false, it goes in this direction. But the calls, when your return statement found, it come in this direction. So you can ask me actually why this is happening, right? Because the compiler use this guy stack, and it has a property that you say first in last out, leave, like filo, whatever it is. Okay, so it is first in last out. Okay, so when it found a return statement here, it will go to the first one, and when this whole method execution is completed, it will go to the second one. Let me show you now where we are at n minus 1 result. So you can say here 1, but I say 1, so again 1 is printed. But after this execution is completed, it will again go to this line for n equals to 2. Let me show you. Now n equals to 1, right? If I press again 2 on n equals to 2, so it is going in this direction, okay. So I hope this is making sense. Okay, so if I do again and again, okay, it will main, and your program code is completed. I hope you enjoyed this video. You have any question, then comment it down. I will see you in a next video with some other more interesting question. With this video, the basic logic, theory, and all these things are completed, and we understand with these 3-4 videos how the recursion works and what is a recursion is. Now let's deep down into the recursion and do some tricky questions of GFG and leaf code. Okay, yeah. So I will see you in the next video. Till then, take care and bye bye. If you have some questions, just comment it down. I will answer them.